Okay, today we're going to finish up section 6.5. We're working on solving square root and other radical equations. So a quick review from yesterday. Remember, we wanted to isolate the square root part. So the first step here would be to divide by 2. We end up with the square root of 3x plus 1 equaling 2. And now to undo a square root, we use its reciprocal power. So instead of a 1/2 power, we're going to raise it to a 2. So we're basically squaring both sides. On the left, the square root and the square cancel each other out. We get 3x plus 1. On the right side, we end up with 2 squared, which is 4. To solve now for x, we're going to subtract 1 to the other side. And then we're going to divide out our 3. So we end up with x being 1. And remember yesterday we said we should really check those answers. So we're going to put a 1 back in here for our x and check it. All right, so simplifying inside our square root, 3 times 1 is 3, plus 1 is 4. The square root of 4 is 2, and 2 times 2 gets us a 4. So it does work. All right, the second type of question we did yesterday had those fraction or rational exponents. Again, we want to isolate the thing that's being raised to that rational power. So we're going to divide out a 2 from both sides. So we have x plus 1 to the 4/3 power equals 16. And now to undo a 4/3 power, we have to use its reciprocal power. So I'm going to give myself a little more space here. So the reciprocal of 4/3 would be raising it to a 3/4 power. Now remember that the top number is your power and the bottom number is your root. And because we're taking a 4th root, we're taking an even root of 16, which means we have 2 possible roots. So plus minus 2, the 4th root of 16 is 2. Then we have to cube that, and that will get us plus minus 8. On the left side, we end up with just x plus 1. So we have 2 equations that we have to solve now. We have x plus 1 equaling a positive 8, and we have x plus 1 equaling a negative 8. If we solve the top one, subtracting 1, we end up with x equaling 7. Subtracting 1 on the bottom gets us x equaling negative 9. And we do want to check both of those. So again, we're going to put a 7 in here. 7 plus 1 would be 8. The cube root of 8 is 2. 2 to the 4th power is 16 times 2 gets us the 32. Checking the negative 9. Putting a negative 9 in for x, adding 1 gets us negative 8. The cube root of negative 8 is negative 2. If we raise that to the 4th power, it's still 16 times 2 gets us 32. So both of these did work. So today we're going to look at what happens when we're solving an equation and we get some extraneous solutions. That term extraneous means it's like an extra solution. It doesn't actually work in the original problem. So that's why we're always checking everything, all of our solutions in the original question. It usually happens when solving a radical that has variables on both sides of our equation. That's why yesterday most of our answers worked. Today we're going to look at ones where we have variables on both sides. All right, so to undo our square root here, we need to square both sides. On the left, it cleans up nice to just x plus 7. On the right side, we have to be careful. We're taking x plus 5 and squaring it, which means we really have x plus 5 times x plus 5. If you remember the shortcut, square the first, twice the product, square the last, you can use that pattern. Otherwise, FOIL this out. X times x would be x squared. Outsides we get 5x, insides we get another 5x, so we have a total of 10x. And our last is 5 times 5, or 25. So what you're going to see today is we're going to get some equations that have x squareds in them. And so because those are quadratic, we need to get everything to one side and then try to factor it. So we're going to subtract an x over, and we're going to subtract a 7 over. We now have one side equal to 0. On the right side, we have x squared plus 9x plus 18. And now we want to try to factor that. Our x squared we're going to break up into x times x. 18, we need two numbers that multiply to be 18 and add up to 9. We could use 6 and 3. So our possible solutions, x could be -6 or x could be -3. That's what would make either of those equal to 0. All right, so now we definitely want to check these. We're going to check them in our original equation, which was the square root of something plus 7 equals something plus 5. Okay, I'm taking those x's out. I'm going to replace them, first of all, with a -6. Let's see what we get. -6 plus 7 is 1. Square root of 1 is 1. On the left side, -6 plus 5 is -1. That does not work out. The two sides are not equal. So this is an extraneous solution. We do not want to include it in our final answer. If we're checking the second option, x being -3, so now we're substituting in a -3. -3 plus 7 is 4. Square root of 4 is 2. On the right side, -3 plus 5 equals 2. Since we are getting something that is a true statement, 2 equals 2, this is a solution. So the only solution to this question is x being -3. Okay, let's try one more of those. Remember, you always want to isolate the radical first. So we're going to bring this 3 to the other side. We then have to square both sides to get rid of our square root. On the left, we get 5x minus 1. On the right, we're going to have to FOIL out x minus 3 times x minus 3. We get x squared. Insides and outsides both give us a -3x, so we're going to get a total of -6x. And -3 times -3 is positive 9. Once again, we want to get everything to one side. So I'm going to subtract 5x, and I'm going to add a 1. So we've got 0 equals x squared minus 11x plus 10. Let's go ahead and factor that. Our x squared, again, we split into x and x. We need two numbers that multiply to be 10 and add up to -11. We could use -1 and -10. So possible solutions here. X minus 1 is 0 when x is 1. X minus 10 is 0 when x is 10. All right, now we have to check those. Remember, we're going back to the original question. The square root of 5 times something minus 1 plus another 3 is supposed to give us our x value. Okay, here we're putting in a 1. 5 times 1 is 5, minus 1 is 4. Square root of 4 is 2. We add the 3 that we had here. We do not get 1. So this one is extraneous. Okay. Trying the 10. All right, let's plug in a 10. On the left side, 5 times 10 is 50, minus 1 is 49. The square root of 49 is 7. If we then add this 3, we do get 10. So we have a true solution here, x equals 10. All right, so what happens if we have two square roots in an equation, but they aren't equal to each other? So like yesterday, we had things like a square root equals a square root. But in today's, notice that we have two square roots, but there's something over here extra. It's not just a 0. We can't simply add the square root of x to the other side and have it clean up nicely. So we're going to actually have to go through this process twice. Our first step is to isolate the more complicated radical. And in this case, our more complicated radical is this 2x plus 1. That's more complicated than just the plain x that we have there. Okay, so we're going to isolate the first radical, the 2x plus 1. To do that, I'm going to add the square root of x to the other side. We end up with the square root of 2x plus 1 equals 1 plus the square root of x. Okay, now we are going to have to square both sides. That's our second step, to undo that square root. The problem is on the right side, this is going to require a little more care. Our left side cleans up nicely to be just 2x plus 1. Our square root cancels our square. On the right side, though, we are going to have to FOIL out 1 plus the square root of x times itself. FOILing that, we get 1 times 1 is 1. Outsides, we get 1 square root of x. Insides, we get another 1 square root of x. And our last term is the square root of x times the square root of x, which is plain x. Okay, cleaning this up a little bit. We have 1 plus 2 square roots of x plus an x. Our next step is to re-isolate that remaining radical. So now we have a square root right here. We want to get that piece all by itself. So we're going to subtract the 1 to the other side. We're going to subtract an x to the other side. On the far left here, we get just a plain x left. On the right side, we just have the 2 square root of x. Okay, to isolate that x squared a little bit more, we're going to divide out that 2. So we end up with x divided by 2 equaling the square root of x. And now we can square both sides again. Okay, we're going to square both sides. We can square a fraction. We simply have to square both the numerator and denominator. So the left side here becomes x squared divided by 4. On the right side, we end up with just an x. The square will cancel the square root. Okay. To clean this up and make it a little bit easier, let's multiply both sides by 4 to get rid of that fraction in the basically to get rid of our denominator. Okay, so we've got x squared equals 4x. Because we have an x squared, we need to bring everything to one side. And now we're going to factor. Now notice this one doesn't have a constant, but it does have a common factor of x, so we can pull out that GCF. It leaves me with an x minus 4 if I divide an x out. And now I can solve those. Adding the 4 over, we get x equals 4. So my possible solutions are 0 and 4. We are going to have to check those. All right, so we have to go back to our original equation. All right, let's check the 0. We've got the square root of 2 times 0 plus 1 minus the square root of 0 is supposed to equal a 1. 2 times 0 is 0, plus 1 is 1. The square root of 1 is 1. So this one does work. Checking the second answer, we had a 4. So let's check that one. 2 times 4 plus 1 is inside our square root. We're subtracting the square root of x, which in this case is a 4, and we're supposed to get a 1. 2 times 4 is 8, plus 1 is 9. Square rooting a 9 gets us a 3. The square root of 4 is 2, and 3 minus 2 is 1. So this one does work. All right, so we have 2 answers here. They both worked in our original equation. All right, our last question. It says a function for the distance in meters at which a car needs to stop is given by this equation. D equals 2 times the square root of v, where v is in meters per second, and it represents the speed of the car before braking. So what is the speed of the car before braking if 8 meters distance is needed to stop the car? So we need a distance of 8 meters. That means d is 8. They're asking us to figure out what our velocity or speed was. So to solve this one, we're going to divide our 2 to the other side. And then to undo our square root, we simply square. So our velocity had to be 16, and our velocity was in meters per second. So 16 meters per second is how fast that car was going. Okay. Send me an email if you have any questions on today's material.